AND stands for Artificial Neural Network. It is a computational model inspired by the structure and functioning of the human brain, and is a subset of machine learning and a key component of deep learning algorithms. Artificial neural networks, ANDs, use learning algorithms that can independently make adjustments, or learn, in a sense, as they receive new input. This makes them a very effective tool for nonlinear statistical data modeling. Pradeep K. Suri, author and researcher. Here's a basic overview of how an artificial neural network works. 1. Neurons, nodes in an N. Artificial neurons, nodes, are organized into layers. Typically, there are 3 types of layers. Input layer, receives the initial data or features. Hidden layers, process the data through multiple layers to learn and extract patterns. Output layer, provides the final results or predictions. 2. Connections, edges. Neurons in one layer are connected to neurons in the subsequent layer. Each connection has an associated weight, which the network adjusts during training to optimize its performance. 3. Activation function, each neuron has an activation function, which determines whether it should fire or activate based on the weighted sum of its inputs. Common activation functions include the sigmoid, ReLU, rectified linear unit, and tan functions. 4. Feed-forward, during the feed-forward phase, data is passed through the network from the input layer to the output layer. Each neuron computes its output based on the input and its associated weights and activation function. 5. Training, and training involves adjusting the weights of the connections to minimize the error between the network's output and the desired output, i.e., the target. This is typically done using algorithms like backpropagation, which iteratively update the weights to improve the network's performance. 6. Learning, through repeated iterations of the training process, an N learns to recognize patterns and make predictions. The depth and architecture of the network, the number of hidden layers and neurons, can vary, and more complex problems often require deeper networks. Artificial neural networks, ANDs, and deep neural networks, DNNs, find applications in a wide range of fields and domains due to their ability to model complex patterns and make predictions from data. Here are some areas where N and DNN are commonly used. 1. Image and video recognition. Object detection and classification. Facial recognition. Autonomous vehicles, example self-driving cars. 2. Natural language processing, NLP. Sentiment analysis. Speech recognition. Language translation. Text generation. 3. Healthcare. Medical image analysis, example X-rays, MRIs. Disease diagnosis and prognosis. Drug discovery. 4. Finance. Stock market prediction. Credit risk assessment. Fraud detection. 5. Recommender systems. Product recommendations, example on e-commerce websites. Content recommendations, example on streaming platforms. 6. Autonomous systems. Robotics, example robot control, navigation. Drones and UAVs. 7. Gaming. Game character behavior and decision making. Procedural content generation. 8. Manufacturing and industry. Quality control and defect detection. Predictive maintenance. Supply chain optimization. 9. Environmental science. Climate modeling. Predicting natural disasters, example earthquakes, hurricanes. 10. Social media and marketing. User behavior analysis. Targeted advertising. Social network analysis. 11. Astronomy and astrophysics. Object recognition in sky surveys. Predicting celestial events. 12. Automotive and transportation. Traffic prediction and management. Vehicle health monitoring. 13. Energy. Predictive maintenance for energy infrastructure. Energy consumption optimization. 14. Agriculture. Crop disease detection. Yield prediction. 15. Music and audio analysis. Music recommendation. Speech-to-text conversion. These are just a few examples, and the applications of ANDs and DNNs continue to expand as the field of artificial intelligence and machine learning advances. Their versatility and ability to handle large and complex datasets make them valuable tools in various industries for tasks that involve pattern recognition, prediction, and decision-making based on data. The choice between using AND or DNN often depends on the complexity of the problem and the amount of data available, with DNNs being suitable for more complex tasks due to their deeper architectures. Thanks.